Bismillahirrahmanirrahim. So today we are going to establish a relation between critical angle, that is theta c, and refractive index, that is theta. So let us say light ray is passing from A to B medium, and A medium is denser medium and B is the rarer medium. So as a result, what will happen? If the incident angle is equal to the critical angle, when the incident angle becomes equal to the critical angle, what will be the value of refraction angle? Angle of refraction. If the incident angle becomes equal to the critical angle, then the refraction angle will become equal to
90 degree.
90 degree. Very good. Did you all forget? We studied critical angle in the last class. That when the light ray passes through the surface of separation, the reflected ray passes through the surface of separation. That time the value of incident angle is called critical angle, and the refraction angle for that it is 90 degree. So if I want to find out the refractive index A eta B, light is going from A to B, right? This is A medium, this is B medium. So A eta B is equal to, we already know that it is equal to sine I divided by sine R. Now here we saw that the incident angle has become equal to critical angle. In case of critical angle, this will happen, right? Incident angle will become equal to critical angle, and the refraction angle R will become equal to 90 degree. So it will be sine 90 degree. So what is the value of sine 90? 1. So anything divided by 1, it is the same thing. So sine theta c is equal to A eta B. So this is the relation. Okay. This is the relation between critical angle and refractive index. Okay. Now let us solve a couple of examples, numerical examples. Okay. Let us say light ray is traveling from water to glass medium. Not water, from glass to water. Okay, so this is our situation. We know the value of theta. We have to find the value of theta c. Can you do it? What is
Oh, sir. Sir, এটা confused question, sir. বুঝলাম না, sir. সঠিক কোশ্চেনটাই বুঝি নাই।
তুমি এই মাত্র জয়েন করছো মনে হয় না? বিকজ যখন অ্যাটেন্ডেন্স
না,
নিচ্ছি
স্যার।
ছিল না
নো 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 ছিলাম না স্যার, কিন্তু এই স্যার আপনি যেটা লাস্ট ডিসক্রিপশন করছেন ওইটা তো এক্সপ্লেইন করছেন, ওইটা বুঝছি, বাট এটা স্যার একটু কনফিউজ।
find the answer
স্যার ওটা আনসার হবে 0.67।
how much
আর উপরে -1টা কেমনে লিখবে?
sin inverse shift দিয়ে sin দিলে sin inverse আসবে
42.07।
42 degree. Okay, now a little bit ago we saw that the relationship between refractive index and the critical angle is this one, but here we have to make sure that the light ray is passing from denser to rarer medium. The denser medium should be at first, the rarer medium should be second, then only you will get critical angle. If the light is passing from rarer to denser medium, then you will never get critical angle, right? So that is why it is important to understand. So light ray should pass from denser to rarer medium. As we can see, light ray is traveling from glass to water. Between glass and water, which one is denser?
গ্লাস।
Yes, glass is denser medium and water is rarer medium. So it is possible to get a critical angle, right? But here, what is written? W eta G. That means the light rays passing from water to glass, right? That is opposite of what is happening or opposite of what we want. We want from denser to rarer. That means from glass to water. From glass to water it should be, but here it is given water to glass. So we need to find the value of glass to water, right? The refractive index of water with respect to glass. We need to find it, and I already showed you that by taking the reciprocal of this one, you can find the value of this, okay? So this is the refractive index. Using this one, you can find the value of critical angle. Nahida, বুঝতে পারছো?
জি স্যার।
So why?
স্যার ওই পাশে ওইটা কি থিটা সি ইকুয়াল টু সাইন পাওয়ার -1 নাকি আপনি এটা কি দিছেন স্যার? এই মোবাইলের কারণে আমি
পাওয়ার -1 sin inverse আর কি, sin যদি তুমি এক সাইড থেকে আরেক সাইডে নাও তাহলে সেটা sin inverse হয়ে যাবে। ওকে
স্যার 1/15 আসে 0.067 না?
কোনটা
না
এটা?
এটা 1/1.5, 115 না,
ও
1.5।
1.5, রাইট। ওকে, সো সব সময় এই ইকুয়েশনটা লেখার সময় তোমাদের যেটা খেয়াল রাখতে হবে যে ইউ রাইট দ্য ডেন্সার মিডিয়াম ফার্স্ট এন্ড দ্য রেয়ারার মিডিয়াম সেকেন্ড। এখানে যেটা আছে সেটা দিয়ে ডাইরেক্ট তুমি এখানে অঙ্ক নাও করতে পারো। মাঝে মাঝে এই যে জি ইটা ডাব্লিউ এটা যদি এখানে ডাইরেক্ট দেওয়া থাকে দেন ওকে, ডেন্সার মিডিয়াম ফার্স্ট রেয়ারার মিডিয়াম সেকেন্ড, বাট এখানে উল্টা দেওয়া আছে তাই না? ইট ইজ আ ট্রিক। তো এটা একটু উল্টা করে তারপরে এবার তোমাকে কি করতে হবে, থিটা সির ভ্যালু বের করতে হবে। আচ্ছা, সো
এটাই ফর্মুলা, রাইট?
ইয়েস, ফর্মুলা তো হচ্ছে এটা। Now I will reverse the question and we will see how we can solve it. That is, sorry, not refractive index. Okay, so this is our question, and while we read the question, let us list the given information. The critical angle of diamond with respect to air, that means the light ray is passing from air, critical angle will be of the first medium, that means from diamond to air, right? While we studied the critical angle, I told you whenever we say critical angle of diamond, that means the light ray is passing from diamond with respect to air, means from diamond it is passing to air. Okay, so T to A. The critical angle that is given theta C as 24 degree. Now find the value of refractive index, okay, refractive index of what? Of diamond with respect to air. So air will be here, okay, so we have to find this one. Now what we know eta is equal to sine theta C, but we have to be careful because whenever we are talking about critical angle, the light ray must pass from denser to rarer medium. Now between diamond and air, okay, which one is denser, diamond or air?
Diamond.
Diamond, and the light is passing also from diamond to air, right? So diamond we will write first and air later, okay? So we can find the value of it is equal to sine theta C. What is the value of sine 24 degree? Okay, whatever the value is, let us not calculate it now. Then we have to check whether we got what we wanted or not. We need A eta D, but here we got the value of D eta A. So we need to make reciprocal of it, right? So in order to find A eta D, we have to reciprocal D eta A. So D eta A is sine 24 degree. So now find the value of 1 divided by sine 24 degree, then tell me the answer.
2.45, sir.
Huh?
2.46.
Okay, whatever the answer is, okay. If you have done it correctly, then this is the answer. Okay. Now you have
refractive index करता हूँ सर. Refractive index करता हूँ ठीक है सर.
ওকে, তো এটাই আর কি যেটা বলতেছিলাম যে মানে সব সময় যেটা বের করতে বলবে সেটা তুমি ডাইরেক্ট নাও পাইতে পারো, হয়তো বা রেসিপ্রোকাল করে বের করতে পারে, তো সব সময় এটা একটু খেয়াল রাখবে, ওকে? আচ্ছা, now our next topic is Mirage. Now Mirage and optical fiber, these are the topic that I would like to explain through a video, okay? And today I did not download the video, so inshallah in the next class we will talk about this, or I will forward you the videos on Mirage and optical fiber. You may watch them. Those are theoretical question, okay? And these are based on total internal reflection, critical angle and total internal reflection. As far as I can remember, in grade 8 also there was a topic of mirage. Am I correct? In grade 8 science book, I saw in the light chapter, there is critical angle and total internal reflection. Also, there is a topic of mirage. Anyway, I will forward you the video and you can watch it, okay? So, inshallah, those two topics, optical fiber and mirage, are for the next class. Today, inshallah, we were going to start lenses, okay? Lens. Okay. So what is lens? A lens is a transparent reflective medium bounded by two spherical surfaces. I will, as I have said the definition, whenever you replay the video later, you can hear it and then write, okay? I'm not wasting any time of the class by writing the definition on the board, because later anyway you can replay the video and hear it what I said. You can pause it and then write, okay? So do that. So again, I will say, what is lens? Lens is a transparent refractive medium. At first, it has to be transparent so that the light ray can pass through it. And as it is, different medium than air, then what will happen? The light ray, when it will enter into the lens, it will change its direction, right? Bounded by two spherical surfaces like this. Okay, so this is called convex lens. Convex lens, where the middle part is wider and the side part, the end part are narrow. That is called convex lens. And the opposite is the case of concave lens, where the middle part is narrower, but the end part are wider. Totally opposite, right? Middle part wide, middle part narrow. And here the end part are narrow, okay, but here the end part are getting wider. So that is the difference between convex and concave lens. Now, inshallah, we will see that what do they do actually, okay? This convex lens is also called converging lens. Why it is called converging lens? Inshallah, we will get to see. As we have already studied reflection of light, you are familiar with this word converging, right? Converging and diverging. And concave, it is called diverging. Diverging lens. Why it is called? We will see. If light ray pass through parallel to the principal axis of a convex lens, then what will happen? After refracting, as this is a transparent medium, light ray will pass through it, right? But refraction will occur. That means the change of direction will occur. So this light ray will change its direction and pass through a particular point on the principal axis, okay? All the ray will do the same, okay? All the ray will do the same. So you can see that all the ray are converging to a certain point. So this is what convex lens does, okay? And the point that it will pass through, can anybody tell me what is the name of that point?
Focus.
Yes,
Principal focus.
principal focus. We already learned this, right? Where the converging ray meet, that point is called principal focus, and it is expressed or presented as capital F. Okay, so the rays that will be incidenting parallel to the principal axis, after refraction, they will meet at a certain point on the principal axis. That point is called principal focus. And whenever rays are meeting, okay, we say that they are converging. They are converging to a certain point. So that is why, as the convex lens convert all the rays to a converging ray, all the rays that are parallel to the principal axis, it converts them into a converging rays, right? That is why it is called converging lens. Now, what is the case with concave? Let us see. What is the case with concave? Now here, let me draw the principal axis, okay, and all the light rays that will incident parallel to the principal axis. What is supposed to happen? Diverging means they will get away from each other, right? Okay, so they will get away from each other. They will diverge. They will diverge, right? Now, will they meet anywhere in the future? Right? As they're going away from each other, they will never meet, right? So if I extend them backward, then there is a possibility, right? If I extend them backward, then you will see that you feel like all the rays are coming from that point, right? So that point is known as principal focus of the concave lens, right? Now here the light ray are diverging. That is why it is also called diverging lens, okay? And when you extend them backward, they meet at a point. So whoever actually watching the rays from here, let us say somebody is observing, this is the eye of someone, okay? So he will feel like the light rays are actually coming from point A, not from infinity, okay? That's how actually we solve the defect of eye. Like some of us have myopia, some of us have hypermetropia. So inshallah, we will learn that which defect is for which people. Like those who can't see the distant object, are they are suffering from myopia, hypermetropia? Which lens should they use? Should they use convex lens or concave lens to rectify the defect? Inshallah, we will get to learn that. Okay, and these are very important of this for this chapter. Okay, now few definitions related to lens. Center of curvature. Now, as you can see in mirror, there was only one spherical surface, right? Concave mirror. So this one was silvered and this one was the mirror. Okay, so we had only one center of curvature, one principal focus. But now what we are doing? We are having two surface, right? See, two spherical surface. So for two spherical surface, what we will get? We will get two center of curvature. We will get two principal focus, two radius of curvature, everything two, right? Because on both the side there will be two. And this okay. So as I was saying, let us see. This is a convex lens. Definitely this spherical surface is a part of a sphere, right? From a sphere, it has been cut off. And this spherical surface, this is also a part of another sphere from which it has been taken. Now, as this is a sphere, every sphere has a center, right? Okay, so that is the center of curvature. You can say this one as C1, and this surface will have another center of curvature over here that can be said C2. Okay, the line that will pass through both the center of curvature. Okay, if you join both the center of curvatures and extend it, that line will be called principal axis. That line will be called principal axis. Okay. Acha. Then we have optical center. Which one is the optical center? In the middle of the lens, there is a certain point, okay, through which if the light ray passes, it will not change its direction. That means what will happen? If a light ray incidents along the optical center, then what will happen? It will not change its direction, it will go straight. It will go straight or parallel to it. Okay, so no change of direction. Understood? That point is called optical center. It is represented by O and it is called optical center. Okay, let me write it here. C1, C2, their center of curvature. and O, this is optical center. And how can we define or find the optical center? The point through which if light ray incidents or passes, it will not change the direction. Okay, the point inside the lens, that one we have to mention. Point inside the lens. I will read out the definitions for you. Actually, better if I send you a picture of this page, right? Because whatever I'm saying, the definition are from the previous book. Okay, so I will send you the picture of this definition because I found that in your current book these are not actually properly written. Anyway, so this is optical center. Then what we have, principal focus, I already explained, right? Okay, light ray will be incidenting parallel to principal axis and they will pass through a certain point on the principal axis, that is known will that will be called as principal focus. So we know that principal focus will be the middle point of this center of curvature and the optical center, right? So it will be here, somewhere here. Let us say this is f1 and this one, this is f2. And the distance between optical center and the focus, it is called focal length. It is called focal length, this distance. So small f1 and this is small f2. Okay, and the distance between as this is a sphere, this sphere will have a radius, right? So that radius, let us say those are r1 and r2, and we know that f1 is going to be half of r2. We already know this, right? These are quite similar to the mirror, spherical mirror, and f2, this will be half of r2. Okay, now then the rules of ray diagram. Again, we already studied 3 rules of ray diagram in reflection of light, and they are of utmost importance. Why? Because if you know these rules, you can draw every ray diagram. I will just tell you what is the lens, what type of lens it is, and I will tell you where the object is. Then you can find or you can draw the ray diagram. Okay, you'll be able to find where the image will be found. So please learn these 3 rules of ray diagram very properly. So so number 1 rule is rules of ray diagram. If the light ray is passing through the optical center, then what will happen? It will pass, it will not change the direction, refraction will not occur. Okay, and this is true for both concave and convex lens. Okay, so the first rule can be shown in this way. The light ray is passing through the optical center, so it is not changing its direction. And the same we can show for concave. Okay, so this is the first rule. If you have an object over here, we know that if you want to find the image, you need 2 refracted ray. Now to find the 2 refracted ray, there must be 2 incident ray from the object. So how you will draw this 2 incident ray? Definitely we can draw 1 incident ray that will pass through the optical center, because we know that if it is passing through the optical center, how the reflected ray is going to be, right? So that is why we will take 1 in this way. Now comes the second one. Second one also we know that if it is parallel to principal axis, then what will happen? It will pass through principal focus. So one light ray is coming parallel to principal axis, then it will, after refracting, it will pass through principal focus, right? But what is the case of concave lens? If there is an object and you took an incident ray that is parallel to principal axis, now you know that it will diverge. But how it will diverge? It can diverge in this way, this way, this way, any way it can diverge. So how to draw the diverging ray correctly, okay, or the refracted ray correctly, you know that there will be a point here which will be called as principal focus. So from here, you will put your scale over here, okay, and then connect these 2 points and then draw the refracted ray, okay. So this will be the OF ray, okay. This is number 2. Then number 3 is the opposite of this one. Number 3 is just the opposite of this one. Here we said the light is coming parallel to principal axis and passing to principal focus. Now we will just do the opposite. The light ray will come through principal focus, and after reflecting, we know that it will pass through parallel to the principal axis. Okay, I will show you, no problem. This is just the opposite direction, okay, opposite of what we learned. So let us say this is the principal focus and light ray is incidenting through the principal focus. Then what will happen? After refraction, it will become parallel to principal axis. And here, in case of concave lens, if light ray is passing, okay, then, sorry, here it will be a little bit different. If the light ray incidents along the principal focus, that means it was going towards the principal focus. We know that here the light ray is already passing through the principal focus, but here we have to say that the light ray is passing towards the principal focus. Then what will happen? After refraction, it will pass parallel to the principal axis. Okay. So these are the things you must remember. Inshallah, if you remember these things, it will be very easier for you to draw the ray diagrams. Okay. Inshallah, we will get to see that. In the next class, we will see how can we form an image in convex lens, how can we form an image in concave lens. Okay. It is just like we found the images in case of convex mirror and concave mirror. Remember in the last chapter, quite similar to that. Okay. There, the concave mirror is similar here to the concave lens, because in concave mirror you get the real image, but here in case of convex lens you will get the real image. Inshallah, how we get that I will show you in the future classes, inshallah. And if you remember, we actually formed images for 6 different places. 6 different places. Object was at infinity, then the object was outside center of curvature, then the object was at the center of curvature, then the object was between center of curvature and principal focus, then the object was a principal focus, and then between principal focus and the pole, right? Remember? So for this 6 position, there we learned the image image for concave mirror, right? But here we will learn the 6 same position for convex lens, because concave mirror is quite similar to convex lens. Okay, inshallah, you will see that. Okay. Okay, so thank you very much for joining. Let me take a look who are there now.